I answered their question. Who can tell me we're supposed to do half of 4.2.4 or all of it, and how did that work? Why is there any confusion, Madison? That's partially correct. They didn't know probably because they didn't write it in their plan book. Okay. Yeah, but Aiden? Okay, but like, so what is the assignment for 4.2.4? Are we doing half of it or all of it?
Half.
Jalen?
You did half of it last week. No, half this week.
Jalen, see me after class for a piece of candy. Guys, this like seriously is making me want to quit teaching middle school. I'm not like making hyperbole right now. There are some of you who absolutely are not doing the minimum. Guys, we did all of 4.2.4. We did all of it. We did half of it last week, assigned on Monday, which, yeah, it was a weird week because then we went bowling on Tuesday and then we had break, but it should be in your plan book on Monday, written down, 4.2.4. The first, like, 5 problems. Some of you even turned it in when you turned in your homework set from last week. And then on Monday, and I talked about this on this Monday, we finished 4.2.4 and had the rest of the homework. And I even told you could do it on the same paper. Doesn't matter. You could do it on 2 separate pieces. I don't care. Come on, guys. It's almost December. And we don't know what the heck's going on. Turn it on. You're at school. Okay, it's time to quit floating by and decide that you actually give a hoot. Can we do that? Can we just act like we care? I don't really like having these conversations, but the fact that, like, a lot of you were probably just sitting there thinking, I hope he doesn't call me, because I'm not sure. What if I checked all of your plan books right now? I don't want an actual answer, but would you have something, like, would you have the math homework written every day how it's actually supposed to be written? Not just 4.2.4, but the numbers that are assigned to go with it. The actual problems that you're meant to complete. Because I don't assign the whole homework every night. I had another person last night reach out to me and say, do we have to finish the homework, like the 4.3.2? What did I assign? 90, what, 3 to 97? My eyes kind of stink, but I can see that from here. Today we're finishing it. Because I wanted to take more time on it. So I'm going to quit wasting time, because we should be doing math right now. Not basics of middle school, how do I write down an assignment. But on the continuation of that, a lot of you didn't turn in your homework. If we want to be specific, from this class, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of you didn't turn in your homework last week. Which I told you, if you didn't turn it in on Friday, you were going to forget. And then I reminded you guys on Monday, hey, if you didn't turn this in, do it today, because tomorrow's Turkey Day, and you're not going to remember. And 13 of you didn't listen. So those grades are in math now. So if you think you're one of those people, you better turn your ears on right now. 4.2.1, 4.2.2, and 4.2.3 were collected last week. 4.2.4 was not actually. And those are what's in math. If it's missing, you better bust a move. We are approaching Discovery Day very quickly, guys. Very quickly. So yesterday we had a mini mastery, which I have not gotten to look at because they were here and I did not make it back here. But the day before yesterday, we were working on 4.2.4, and we essentially made it through 86, right? Talking about when x is an amount that we know. And we kind of had our brains blown by the idea of x being a half. And then this square is technically smaller than this square. Remember talking about Stretch Armstrong with all that stuff? Give me,
smaller than the normal x.
Yeah. Give me like half a nod or something if you're like kind of with me. You remember working with the algebra tiles and talking about x being 6 or x being a half. So I forget if we left on this or if the afternoon class was the one that left talking about this. But we want to talk about the perimeter, and we can talk about the area, but the area is easier. We want to talk about the perimeter of these two different shapes. So I don't think we need to get out the algebra tiles, and a lot of times they're a distraction. But go ahead and with your group, and make a quick little sketch of this in your notes. So go ahead and if you haven't, put a header on your notes. We're still in 432, so we can continue previous notes. Guys, those of you that are organized, like I can tell on your homework, and it's awesome, and thank you. Like I really appreciate that. Like you could be saving a lot of paper. We don't often probably have a whole page of notes. So if you want to continue from the previous day, you always can. But today we're on 432. Still talking about the distributive property. But go ahead and sketch this in your notes real quick. So make an X rectangle and label it X. Make a 1 square, label it 1. And another 1 square, try to make them the same size, not like me. I'm not very good at this. You have graph paper, so it can help, but don't line your X up on the graph lines, like that will goof up in your head. There's a 1, and another 1. So, the difficult part here, actually I'm not even going to tell you the difficult part. As a team, work to determine the perimeter of this object. So perimeter, right, the outer edge. Talk with each other, see what you think. I don't know why that made that. I gotta reorient my screen, sorry guys. Something's goofed up. Really goofed up. It is really quiet in here. All right, I'll give you a more specific question. How can we figure out the length over here? Here's what I want you discussing. How do we deal with the perimeter on the right-hand side over there? I am not going to say anything for at least 90 seconds, probably a couple minutes. I want you to talk with each other, figure out some ideas, and write something out what you think is the perimeter. I think this table has migrated over here. All right, so I hear a couple arguments happening. We know the dimensions of our X tile. Right, what are the dimensions? Actually, I need a random card a lot more than I have been lately. These are still in the order from the other day. So if you got called the other day, you're on the bottom. If you didn't get called, you have a higher probability. Labiba, what are the dimensions of the X tile? Pass. Hold on, I'm going to come back to it. Wow, my smart word screwed up. This tile, what are the dimensions? Not of the shape we're looking at, but of just the X tile. You can pass if you want, but we did this the other day. We wrote them down in our notes. Aiden, what are the dimensions of our X tile? Like, how big is this?
That's 1.
And then how big is this? Exactly. So our dimensions of our X tile are X by 1. And my smartboard's real goofed up. So if I write anything that is not perfect, it's very hard for me to edit right now. And then our 1 tiles, 1 by 1, right? 1, 1, 1, all the way around. So when we come over to this side and we talk about this length and this length, we don't really quite know what they are because it's x, but not all of x. Jalen?
I estimated that it was 1 because the 1 square.
No! You're trusting what things look like. Remember, we said we don't know what size that is. We can't trust what it looks like. Don't estimate. You can't do that.
It's half of x.
You can't do that either. So if that's half of x and you're saying x is 4.
So it's X.
Quit trusting what things look like. You can't trust your eyes.
So it's X.
Don't just shout things out. If you're on this side for foundations, we were just having a reminder conversation about this. There are appropriate ways to engage and not appropriate ways to engage. Like, try to walk that line. Adrian? Why? The entire length over here is x. If I take away this chunk and I take away this chunk, right, which is what's there and there, I'm missing 2. We know what we're missing, but we don't quite know what we actually have, right? The x, we don't know what that is, but we took away 2 from it. So Jalen, I agree with you. What it looks like those are 1s, and it looks like x is 4 here, but we can't trust that. Okay, you got to be careful making those assumptions or inferences, or you got to know it for sure. So if that chunk is x minus 2, then we have an x here. How much at the bottom down here? 2. I know my smartboard screwed up. 3, 4, 5, 6, 7, 8. Right? That's all our 1s. So we have the x. We have 8. And then we have x minus 2. This is what I saw written on a few people's papers. The 8s we can count. We can just walk around and get the 1 edges and count it. So then we have to look for like terms or anything that we can do. Can I do this?
No.
Why not, Sky?
Because we don't know what x is.
We don't know what x is. I can't take away 2 from something that I don't know what it is. So the parentheses don't matter now. If I can't do what's inside of them, they don't matter. If I group my x's together and I group my constants together, Joey, do you know what I have simplified? I put my x's together and my constants together.
Nope.
How many x's total are up here? 2 x's, right? Plus what? How many constants do we have? 8 and a negative 2, so 6. Our final perimeter here is 2x plus 6. Questions? As you're about to do B, and I'm going to random card people, and I don't know if I'm going to let you pass because you can ask us questions as you work. Questions on A, because we're going to move on to, or I guess. We're going to move on to the next one. I need you guys to know what's going on. Questions? Nothing? All right, check out the next one. Work with your group to determine the perimeter down there. It'd be helpful if you do a quick sketch of it. And I need to climb up here and adjust this projector. I think that's the issue.
Wow.
Well, my smartboard has a couple spots that are bad, and I have to kind of avoid those. Huh?
Our teacher jump on the desk and walk around and explain stuff last year.
Oh
Yeah,
my god,
this is
you're
McGuire.
He was
I'm just trying to get the
Remember when he fell through the wall?
fixed.
He broke his glasses this year when he fell off and just saved an invisible pair.
Wait, really?
Yes. My sister told me this.
Oh my god. Dang, he must
No.
It's when I orient, it's getting all screwed up. So now, of course, it's going to be off that I move the, it's over here, it's really bad.
I'm a bird.
Oh, I gotta tell you about Discraft later at the end of class. Yeah, it's one of the disc companies. Like, we actually just picked up Paul McDonough. He signed. They're the ones who gave the over $1 million contract, which is like unprecedented. Questions you're on teamwork, so I'm gonna check in with you. Hey, real quick, I need Nathan and Greg to come out here real quick.
What? Outside of X squared. On the perimeter of X squared is X and X or X and X. Where?
Yeah. What? That's my
Remember, as you out wise you
I know we're doing plans, so why would you say
Riley, you knocked her with the sacred text.
what book is more bad?
All right, we're gonna rapid fire. Eva, what is the length at the top? Give me both pieces of it. The top of the shape. Like, what do I have up there? X and a 1, right? On the left side of my shape, Casey, what do I have? X and a... And 2 at the bottom, right? Because we had 2 lengths of 1 right there. Ava, what do I have on the...
Here.
Ah, come on, Ava. Layla, what do we have across the bottom? Yeah, X. Okay, since that was easy, what do we have right here?
1.
Ooh, well, 2 ones.
Well,
yeah,
yeah,
1 and 1.
And then we got another 1, another 1, another 1.
Sure. No, actually.
Okay, 8 and 1 and a 1 and a 1 and a 1.
Then you got another 1 and a 1.
And another 1 and a 1. But, fine.
Then you got an
What's
X minus 2.
this?
And you got an X minus 2.
X minus 2 because this length missing of 1 and that length missing of 1. Hold on. So now collect them together as we walk around.
I want to do it.
Right, so, sure, 80, fine, but you gotta, like, tone it back a little bit. How many x's, because remember, we deal with variables first. How many x's do we have?
4. Technically, you have 4.
So this doesn't affect the x actually,
No.
right? So I like how that, like, there was a bit of, like, wait, well, really, this isn't quite x, right? It's x minus 2, but I can't do that. So the x is still x.
But then the minus 2 will go towards the 10.
Ah, so we have 4x. Then get your constants.
Plus 8.
2, 5, right? 7.
9.
Ooh, 7 plus 3,
I'm sorry.
10. Then the negative 2.
Which equals 8. So 4x plus 8 equals the answer. Yay.
So this is 4x plus 8. If you got 4x plus 8, give yourself a pat on the back. You did a great job there.
I got 2x minus x.
Now, do you see where your mistake was? That's the question. If you didn't get 4x plus 8, do you see what went wrong in your process? Questions? Hold up. Questions? All right. So if we look at this shape, go ahead and sketch it in your notes real quick. We have an x squared, we have an x, and 3 single tiles. Now I'm curious how you draw it on your graph paper, not knowing what x is. Like, if you don't know what something is, but yet your paper has boxes and you know what those boxes are, give me your eyes for a second. Because this is one of those questions where, like, I kind of wish I taught college to get really, really deep thinkers. So I want to see if you can think real deep. What? I'm going to test and see, can you think deep?
Oh.
And you responded kind of immaturely. Yeah, that. Can we draw something we don't know?
Yes.
Yeah.
My hair looks like that.
Give me a hand if you want to make an argument one way or the other. Eva.
Okay, so first I said yes, then I realized no. Because we can't, like, physically draw something if we don't even know what it looks like. As in, like, saying, hey, I'm going to draw a bird that I've never seen in my life before.
Yeah, I'm going to draw the invisible bird, right? No one can see him. This is what he looks like.
He's a bird. Beautiful.
So the idea of drawing something we don't know is really tough. I'm teaching. You're looking for me. He's doing his own thing. Unless Mr. Sherg wants to learn math, it's fine. So now, just the invisible bird. Now, draw this on your graph paper. If we say x is 5. So don't erase the other one you drew. Hey, but first, hold on. First, write in your paper x equals 5, and then draw that drawing. And I'm going to pull down my graph paper and do the same thing. If x is 5, what does this look like now?
I already drew it like that.
And if you already, then go on and draw an x is 3 version. You can see where we're headed.
OM tubular.
What?
Would you like to know?
I did it right, so I scored this.
Wait.
Bless you. Yo. It might be. I don't know.
What did that mean?
So what do you mean by that? So that's not the right use. But you understand what it means? So it has nothing to do with whether things are perpendicular to the ground, right? So I need to see what that means. This is not fun. Also, I read a couple of opinion journals. Very funny how, bro, this is what I feel like. So now that I know x is 5, I think we can do a little bit more than we've been able to do before. If x is 5, what's the length of this section over here? No, 4, right? Instead of being x minus 1, we know now that it's actually 4. What is the length up here? 6 over here. 3. Then, well, we got our 1, 2, 1, because those have been counted. Well,
no, raise the one on the bottom because we can do the whole bottom.
what's the whole bottom?
8.
5 and then 3 extras, right? So this is 8. And then a 1 and a 1.
Yep.
So what's our total perimeter here then? Do you got
Basically, the total perimeter is
19? Can we verification?
I got 21.
Check math. 9, 10, 12. Wait, what?
Wait, what?
20. I get 26, I think, guys.
Yeah,
Check your math. We need to check our addition skills.
Oh, I got 26. I still got 21.
I think it's 26.
It is 26.
All right,
Yeah,
let's try this again. If x is 3, draw that. I know a lot of you love drawing. I have to get you to stop drawing. So draw the new shape. If x is 3. Did I get something wrong? Because the different screen size, it actually comes down to ratios. Like, legitimately, it's because the math. It's mimicking this screen size up there, well, depending on how the screens are set up and when I copy it and whatever. So it takes a picture, but then it has to resize the picture. So it like stretches it in a different way. Yeah. And then calculate the perimeter, because apparently that's where we struggled last time. Then calculate the perimeter, because that's where we struggled. Wait, that's x is 4. 1, 2, 3, 4. You made x 4. We want to make x 3. Because here's your x of 5, right? 1, 2, 3, 4, 5. Bunch of 5 for the x. We were supposed to next make x equal 3. That's x squared. So that means it's x by x because it's a square shape. That tile, if this like we did this on Monday, that tile isn't actually that tile's name is x squared. That mathematical function tells you to multiply a number by itself. So the reason we use that little square is it means I have x times x. If this is like off topic of our notes, if you had x to the third, that would be x times x. X. So that little 2 doesn't matter for what we're doing until we know what x is. If x is 5 up here, this now is going to be 5 squared because the dimensions of that square are 5, which that's actually 25 because there are 25 squares inside of it. Now you actually draw this 4 by 5. So if we imagine it's actually 5 by 5, but yeah, those x squared should be squares, not rectangles. Like you were asking about the screen. So, and what? Okay, you can't do it. So you can do it then. You're not saying anything that means you can't. You're not saying anything that means you can't. You're just saying what we can do. I'm going to come to you on that one and ask you how to do it, so you better figure it out. Alright, if x is 3, check if I draw this correctly.
Wait. Oh my god. X is 3 now.
There. Is that correct?
Yeah.
So now I want to clarify, because I realize some of us haven't worked very much with this and we're still a little bit confused. Our x squared tile, that's not x2. That's x squared, and that's the math function, the thing we're doing, but also because it's a square. Okay, so I know sometimes things look a little weird on the screen because it changes the size depending on the zoom and different stuff like that. That's named x squared because it's a square. What it means is it's the number times itself, because if we talk about the area of the shape, it's length times width. Right, so it'd be x times x. So we count up our perimeter here with x being 3. What's my length at the top? Anybody? 4. Well, these are all 1s. 1, 1, 2, I guess. Length at the bottom? 6. Thank you, Isaac. Over here, we got 1s. What's your perimeter when you add it all up?
18.
18. Anybody have a discrepancy with that? Anybody have an issue?
No.
Layla?
I did -2.
What do you mean -2?
I did 3. I did 3 minus 1 on that side.
Like, here?
Yeah.
So 3 minus 1 gets you 2.
None.
Unless you accidentally thought it as 1 minus 3, and then you'd get -2, but
I did.
I got 22.
check your math. Did you make x the right size?
Well, X was supposed to be 3, wasn't it?
Why aren't you drawing on the graph boxes?
Is that
Why aren't you using your graph paper to use the squares? Dude, come on, you're making things harder on yourself. We're going to skip x equaling 2. Draw this if x equals 1, and then Casey's going to talk us through how to do it.
Wait, what?
Figure it out?
Oh, I already did it.
No, wait, what is that? Why did 1 change?
I love that.
Hey, let me ask you a question. Let me ask you a question, because I realize we might have some confusion. Give me your eyes real quick. Hold on, stop talking. Sorry, this needs to happen. If I change what x is, like between x being 5 and x being 3, does it impact my 1 box?
Maybe.
No! You are working on graph paper for a reason. Your 1 square, if what you're saying is more important than what I'm saying, leave. Go sit in the office, have your conversation there, and then you can call your parents and explain. When x changes, this guy doesn't change at all. My 1 square, 1 square. My 1 square is a 1 square. We should be drawing on the squares of our paper, guys. This whole like writing diagonally, starting where, guys, you're in middle school. Use paper how it's meant to be used. Start at the left, start at the top, line things up. Don't just make things all crazy whopper jawed all over the place. So we make x 1 my 1 square is not impacted. My 1 square is still a 1 square. Then my x rectangle, what happens with the x rectangle? Gets smushed to what? My x rectangle is now a 1 rectangle, which is a square. What about my x squared if x is 1? It's still a 1.
What?
So here's my 1, here's my x squared, and this is what my shape should actually end up looking like.
I did it right and wrong.
Guys, this is what I was trying to get you to visualize yesterday with x changing size. X could be the exact same thing as the 1 tile. And my x rectangle, if I squish it down, or stretch Armstrong it down, or whatever you want to think, to only being 1 tall, we know it's 1 wide. So if it's 1 tall, it becomes a 1 square. So when x is 1, they're all the same. Questions? Aiden?
Why? I don't get that though. Like,
What don't you get?
oh, never mind. I get it. I get it. Smells like gold coffee.
All right, try 89. This is switching gears a little bit.
Oh,
So if we use an x for the any number. Magicians used to do this on TV, and I thought it was actually magic. If we think of a number, and we call it x, then, this doesn't take conversation, triple it. So what do we do to the x to triple it? Right? Times 3. Add 1.
3x plus 1.
But then multiply the thing we have now by 2. Brandon? I can put the thing in parentheses and multiply the whole thing by 2. So I want to know what we then get at the end. Yeah, what'd we say? I forget if it was Monday, Tuesday, when it was. What's the key to doing these correctly? Well, yeah, that's what it's called. What did I tell you? Like, we gotta put on our paper the arrows. So, guys, write this out. If you haven't written this in your notes yet, write that out. And then draw the arrows. You got this, Riley?
Wait, is the first arrow going to the x or the 3? Whoa.
Yes. It's going to the 3x, because the 3x is one thing. So this becomes 6x plus 2.
I'm so tired. I probably should take
This is so fun. I wonder about it.
Then, on your own, because we want to check these skills, because, guys, I am nervous that some of us are just floating by on other people's skills. Try...
Sorry, Riley's did something.
Riley, can you handle yourself in class?
I tried to drink water, but there was no water left, and it sprinkled the bottle.
Okay. I don't know how that's funny. I really need to find a job in high school. Try 90. First in A, well, okay, you can figure this out. All we want to do in 90 is rewrite those in a new way. So in A, we're doing what we just did, but in B, we're going to go backwards. We're trying to rewrite them in a different way than how they're shown. Bless you.
Thank you.
You're welcome.
Draw your arrows. got 2 minutes left. They're releasing a little bit early. What do I absolutely want to do first? I'm just going to go anybody because we're running out of time. What do I need to do first here? Anybody. Just arrows, right? Boom.
Yeah, boom.
Boom. What's this become?
8x.
Plus 12, right? 8x plus 12. Real fast to make sure that you can do this on your homework. On one like this that says rewrite in a new way, instead of multiplying both things, if we're going backwards, we're looking for what could we divide by. Don't apologize, you're right. So, Layla, what could we divide by here that they both would work nicely with? 3, 6, 2. Yeah, there's a lot of options. So if we divide them both by 6. Hey, give me your eyes, because this is where you're not going to know how to do your homework. I'm worried that some of you don't care. That 6 goes out here because it is then what we could multiply by to get back to the original. What's 12x divided by 6? 2x. 18 divided by 6. And that's how we do what's called factoring. And we will keep doing this for a long time. Have a great day, guys. So I got a set of Casey. I need to. So when we look at, if I can find the right tab. Well, first we really need to talk about yesterday. At least I think. How did the lesson yesterday go? With construction? What were some things that you discovered or surprised you or were interesting, or maybe like the book tried to steer you one way and you didn't end up that way and you're like, haha, I tricked you, book? Like what was interesting? OP? Hey Caitlin, did you hear me calling Octavio? Gabe, did you hear me calling Octavio? Do you have that social filter that you realize it's rude that you're carrying on your conversation while we're having class? Huh? Well, Caitlin was talking to you, so you're equally like part of the conversation. Caitlin, do you have the social filter to know what's appropriate and not? So guys, this keeps happening, and it has to stop. I hate that I'm having to have these like serious conversations, but y'all are being disrespectful to each other, and that's not the Phoenix that I know and love. If you want to be part of this program, you need to figure out your behavior. When you're in class, and you don't just get to choose to do whatever you want. If you can't handle yourself in class, I don't need you here. Go to the office and sit there, call your parents, tell them you can't handle yourself at school. We'll figure out a plan for you. But I feel really bad because Octavio's trying to give an answer, and like 6 different people are carrying on a conversation. Knock it off, or leave. Those are your options. Okay, I love you dearly, but I will not have you in here disrespecting your peers. That does not fly. So sorry, Octavio, try again. And by the way, everybody should have graph paper out ready to roll, whether it's continuation from notes yesterday or new notes today. Once your plan book's done, you know what to do. Octavio, what was interesting yesterday?
The quadrilateral has angles that matter.
Are you saying any quadrilateral?
Yeah.
Anyone agree with, like, I'm not going to say whether that's right or wrong. Anyone get the same conclusion from yesterday that quadrilaterals have 360 degrees on the inside? Do you want to add on to that, or are you just agreeing?
I'm just agreeing.
Okay. Octavio's right. That's an accurate discovery. Quadrilaterals, any quadrilateral, the inside angles will make 360 degrees. Now, a really cool thing we can do to start proofs like that, yeah, let's blow your brain. I'm going to recycle some of the Black Friday papers because they're really bright and easy to use. If I make a triangle, triangle, right? Do we agree that this is a triangle?
Yeah.
Now, specifically, what type of triangle? Right triangle. You are right. Haha. Jokes. So, if I take this triangle and I shade the corners, I would do this on the smartboard, but I can't. Like, what I want to do just can't. I need physical stuff. So, I'm going to color the corners so we know which ones were the outside corners, because then I'm going to rip this apart, and I'm getting Sharpie all over my desk.
Is that a wipeable desk?
Nope. The wiping desk is wipeable. It just determines whether or not the wiping does anything. All right, so here's my 3 corners. Right, and I think this is part of a lesson, but I forget if we skipped that lesson or not. Check it. Nah. Wait. So I have one corner here, right? One corner here. One corner here. Right? Mm-hmm. I feel like there should be some suspenseful music, like when you watch Magnet. Great suspense, right? Peyton's back there. She's like, this is lame. Any predictions?
I have a prediction. Speed arrow. Oh, it's magic.
If you take, that's it. So that was the end of the drum roll. If you were, that was if you take any two-dimensional shape, now specifically we're talking about a triangle here, but you rip it apart and you put the corners together with each other, you will find special relationships. In a triangle, the 3 corners add up to what? 180, right? We can see that now. It's a straight line. It made, like the bottom is straight. That's 180 degrees. We've talked about that. If you take a square or a parallelogram or any weird quadrilateral and rip the corners apart and put them together, it'll make an entire like circle, 360 degrees. And the outside of it would be awkward because it'd be your rips. Beyond that, anyone want to make a hypothesis of how my shapes grow? If we said that a triangle has 180 degrees, we said a quadrilateral has 360 degrees, what do you think about a pentagon? Really? Jessica?
720? Oh.
George?
500. Oh, wait.
540, yeah.
Who said, oh, wait.
Every time we add an edge, we add 180 degrees to the inside.
What's a 2?
There is no 2. There's no two-sided, two-dimensional shape. It's not a polygon. So it can't close.
Oh, yeah.
Remember, polygons have to close. This rule works for polygons. There is no two-sided, two-dimensional shape. It can't close. I can't connect. It's like somebody saying make a shape with your arms. And you're like, I can't. Now like this, but that's 3 sides, right? Like that's a triangle. I got 180 degrees there. Hold up. What? A two-sided polygon? Not if they're straight lines.
Football.
You gotta be straight lines. Polygons are only with straight lines.
So a circle isn't a polygon?
No, a circle is not a polygon. Now it's a closed shape, but a polygon, guys, this goes down to root words. What's poly mean?
Many.
Many or multiple, right? A polygon is a shape of multiple sides. A circle technically isn't. It's a closed shape. It's a geometric shape.
You could show out to
Zero going.
coordinate. You could draw a right triangle and retrace it with another color.
Oh, yeah. So that isn't even what we're doing today, but bringing things back to that. What else about yesterday's lesson? Like when you guys did those constructions of, I didn't mean back, although that is where I meant to go. So in the first problem that you guys had, it was like build this shape with these specifics? Did you guys all end up with the same shape, or who can talk to me about what happened there?
So we all had the same shape, but like it would either be flipped, like, but like it was the same. All of ours were the same.
They did. Did anyone have any that were different at your group? Your shapes ended up different? You should have. Like, now, you might have ended up with all the same shapes. That happens. But you wouldn't necessarily have had all the same shapes. Yeah, it depends on where you put that angle. Yeah, let's go ahead and do today's lesson.
You didn't stop the recording.
Oh, I picked up the same recording. You're right.